guys, in today's video we are going to be covering the different variable types. Let's begin. The four types of variables are categorical, ordinal, interval, and ratio. Let's take a look at categorical variables. Categorical variables are also known as nominal variables, and they are values that have no numerical meaning. In other terms, the value has no numerical weight. What this means is that the number assigned to an observation within a category does not actually hold the numerical weight of that number. Categorical variables are discrete. Discrete variables are those that are separate, indivisible values. There are no in-between values like decimals. Each value is treated as an individual category, and those categories are then compared to one another. Some examples of a categorical variable are gender, race, sport jersey number, hair color, and college major. Categorical variables are a way to separate and organize observations by a feature or characteristic. Next, we have ordinal variables. Ordinal variables are also known as rank ordered. Ordinal variables have unknown intervals between values. They are discrete, and the rank is represented by integers. A great example is race times. Alright, now we have interval variables. This variable has equal intervals between the values. It also has no true zero. What it means to not have a true zero is that the presence of zero indicates variable absence. We often think of zero as meaning the numerical concept of nothing or lack of change. But in this case, zero indicates the absence of the variable. An example of this is temperature. When the temperature outside reaches zero, it doesn't mean that there is no temperature present. Interval variables can be continuous or discrete. This all depends on how the variables were measured. A continuous variable is one that has infinite possible numbers that fall between two values. Lastly, we have ratio variables. Ratio variables have equal intervals between values. They also have a true zero. So the presence of zero indicates that complete absence of the variable. Because there is a true zero, we are allowed to make comparisons such as twice as large and 4 times as much. Just like interval variables, ratio variables can be continuous or discrete, all depending on how the variables are measured. Some examples of a ratio variable include height, age, and wealth. Question: sometimes you can treat discrete variables as continuous variables, but when? Answer: we can treat discrete variables as continuous when treating discrete values as individual categories becomes too overwhelming or complex. Let's look at two graphs to visually see the difference. The rule of thumb is that if you have less than 5 levels, treat the variable as discrete. If 6 to 11 levels, try to avoid or recode. And if there are more than 11 levels, treat the variable as continuous if the data resembles a normal distribution curve. Let's do 2 examples. Pause the video and read over the problems and try to solve on your own. Okay, so for example 1, the variable would be categorical and discrete. This is because we can choose between different categories of activities. Each activity is treated as its own category and then compared to the other categories, or in this case, the other activities. For example 2, the variable would be ratio and continuous. This is because weight can be an infinite number, meaning it can have infinite decimal places, and has a true zero, allowing us to make comparisons like the rat gained twice as much. Alright, that's it for this video. Thank you for watching. Our next video topic is going to be graphs. Please leave a comment if you have any questions or would like a specific topic to be covered. Also, make sure to check out the description below where I have the link to my tutoring profile if you would like to set up a session with me. Thanks again. Bye!